Welcome to Senior High School Math Series. Let us have deriving the equation of a parabola under PreCalculus. This video tutorial will be for the preparation of our discussion on the conic sections, particularly the parabola. First, let us have the definition of the parabola. A parabola is the set of all points in a plane which are equidistant from a fixed point and a fixed line of the plane. The fixed point is called the focus and the fixed line is called the directrix. We're going to derive the formula or the equation for the parabola based on the explicit definition. This is from Analytic Geometry, written by Gordon Fuller. Before we continue, let us have a recall of an important concept that will be used in our derivation. That is the distance between 2 points. The distance between 2 points, x sub 1, y sub 1, and x sub 2, y sub 2, plotted on a rectangular coordinate system is given by d is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Now let us represent our parabola using the rectangular coordinate system. So we have the y-axis, the x-axis, and the origin. In coordinate geometry, during junior high school, you learned that in solving problems using geometric figures, we make use of the axis and the origin so that we will be able to minimize the use of variables. So for our parabola, let our parabola pass through the origin, that is 0, 0, and let us use that to be the lowest point of our parabola, and that will be the vertex. From the definition, the parabola is the set of all points that are equidistant to a fixed point and a fixed line. Now, let us have a point on the parabola represented by P with coordinates x, y. So this point P is equidistant to a fixed point and a fixed line. Let us have the fixed point to be on the y-axis so that its coordinate will be 0, c. The x-coordinate is 0, the y-coordinate is c. And then let us have the fixed line. The distance from P to F must be equal to the distance from P to a fixed line. Let us call this D, or the directrix. Now, if the origin is a point on the parabola, or the point 0, 0 is a point on the parabola, then the distance between the focus and the vertex, or the origin, is equal to c units. And since the origin is also a point on the parabola, it must be equidistant to the focus and the fixed line. So therefore, from the origin and the fixed line, or the directrix, the distance is also equal to c units. Therefore, the directrix passes through the point 0, negative c. And if the directrix passes through the point 0, negative c, therefore, the equation of the directrix is y equals negative c. Now, the point of intersection between the vertical line passing through point P and the directrix, let us call it P prime. It must be passing through the coordinates x, negative c. Since this is a vertical line passing through point P, the point on the directrix and point P will have the same x coordinates. Now that we have the important points on the figure of the parabola, we can derive its equation. From the definition again, P is equidistant to F and the directrix, or the focus and the directrix, where the focus is the fixed point and the directrix is the fixed line. So if we're going to use the distance between 2 points, then we say PF is equal to P prime, where PF is the distance between the points P and F, and P prime is the distance between the points P and P prime. Using the formula for the distance between 2 points, for PF, we will have the square root of x minus 0 squared plus y minus c squared, and for P prime, we will have the square root of x minus x squared plus y minus negative c squared, that will be y plus c squared. Now we can get rid of the radical symbol right away by squaring both sides. Then we can have x squared, y minus c squared is y squared minus 2yc plus c squared. On the right hand side, x minus x is 0, so we have y plus c squared, that will be y squared plus 2yc plus c squared. Notice that we can cancel some terms. If we add negative c squared to both sides, then c squared will cancel. Also, let us add negative y squared to both sides of the equation, then y squared cancels. So we have x squared minus 2yc equals 2yc. Now let us add 2yc to both sides of the equation. We will have x squared is equal to 4yc. Hence, for a parabola passing through the origin, and notice that it opens upward, the equation is x squared equals 4cy. In the previous slide, our parabola opens upward and it passes through the origin at its vertex. This time, let us have our parabola to open downward, and still the vertex will be at the origin. Again, let us assign a point P on the parabola with coordinates xy. So this point P will be equidistant to a fixed point called focus and a fixed line called the directrix. The focus this time will have the coordinates 0, negative c. Notice that the focus is always interior to the parabola, and it is collinear with the vertex of the parabola. The line that contains the focus and the vertex of the parabola is called the axis of symmetry. The directrix this time will be passing through the point 0c. Since the distance between the vertex and the focus is c units, the distance from the vertex to the directrix must also be c units. Hence, the directrix intersect the y-axis at point 0c. So the equation of the directrix this time is y equals c. The vertical line passing through point P intersect the directrix at a point with coordinates xc. Let us call it P prime. So again, we have the important points in our figure. We can now derive the equation for the parabola that opens downward with its vertex at the origin. Using the distance between 2 points, we have PF, that's the distance between the points P and F, is equal to P prime. That is the distance between the points P and P prime. So we have the square root of x minus 0 squared plus y minus negative c squared, that will be y plus c squared. P prime, we have x minus x squared plus y minus c squared. Getting rid of the radical symbol, let us square both sides. Then we will have x squared. Square of the binomial y plus c is y squared plus 2cy plus c squared. And then the square of the binomial y minus z squared is y squared minus 2cy plus c squared. Again, we can cancel some terms by adding negative c squared to both sides. C squared minus z squared is 0. Also, let us subtract y squared from both sides. We will have y squared minus y squared is 0. Then we are left with x squared plus 2cy on the left hand side and negative 2cy on the right hand side of the equation. Subtracting 2cy from both sides, we will have x squared is equal to negative 4cy. Hence, the equation of the parabola that opens downward with vertex at the origin is x squared equals negative 4cy, where c is not equal to 0. Notice that in the parabola that opens upward, passing through the origin, the equation is x squared equals 4cy. Therefore, if c is not equal to 0, then the equation of the parabola that opens either upward or downward will be equal to x squared equals 4cy. If c is negative, the parabola opens downward. If c is positive, the parabola opens upward. This time, let us have the parabola that opens either to the right or to the left. So let us have the rectangular coordinate system. And let us start with the parabola that opens to the right. Still, it passes through the origin at its vertex. So let us assign point P with coordinates xy. This point P is equidistant to the fixed point and the fixed line. The fixed point is the focus, this time with coordinates c0. And the directrix will have the equation x equals negative c. Since the distance between the vertex and the focus is c units, the distance from the directrix to the vertex must also be c units. Hence, the directrix passes through the point negative c, 0. So the equation of the directrix will be x equals negative c. The horizontal line passing through the point P and intersect the directrix, the intersection will be at point P prime with coordinates negative cy, so that we have the important points on the figure. Using the distance formula between 2 points, we will have PF equals P prime. The distance between points P and F will be x minus c squared plus y minus 0 squared. And the distance between the points P and P prime will be the square root of x minus negative c. That will be x plus z squared plus y minus y squared. Squaring both sides will get rid of the radical symbol. So the square of the binomial x minus c squared is x squared minus 2cx plus c squared. Y minus 0 squared is y squared. On the right hand side, we have x squared plus 2cx plus c squared, and y minus y is equal to 0. Subtracting c squared from both sides of the resulting equation will have c squared minus z squared, that is 0. Also, subtracting x squared from both sides, we will have x squared minus x squared equals 0. Then we have y squared minus 2cx equals 2cx. Adding 2cx to both sides of the equation, we have y squared is equal to 4cx. Hence, if the parabola opens to the right and the vertex is at origin, the equation is y squared is equal to 4cx. Lastly, let us have the parabola that opens to the left with vertex at the origin. So we have point P with coordinates xy. This is equidistant to the focus with coordinates negative z0, and the directrix with equation x equals c. The point of intersection between the line containing point P and the directrix will be P prime with coordinates cy. Using the distance between 2 points, let us solve for the distance PF and the distance P prime. So PF is equal to the square root of x minus negative c squared, that will be x plus c squared, plus y minus 0 squared. And the distance P prime will be the square root of x minus c squared plus y minus y squared. So squaring both sides will get rid of the radical. The square of the binomial x plus c will be x squared plus 2cx plus c squared. Y minus 0 is y, so that will be y squared. The square of the binomial x minus c squared will be x squared minus 2cx plus c squared. Y minus y is 0. Subtracting x squared from both sides in the resulting equation, we'll have x squared minus x squared 0. Also, subtracting c squared from both sides of the resulting equation, that will be c squared minus c squared 0. So we're left with y squared plus 2cx equals negative 2cx. Subtracting 2cx from both sides, we'll have y squared is equal to negative 4cx. Hence, for the parabola that opens to the left and vertex at the origin, the equation is given by y squared equals negative 4cx. Let us summarize the result. The equation of the parabola with vertex at the origin 0, 0. The parabola is with the equation x squared equals 4cy if the parabola either opens upward or downward. If c is greater than 0 or if c is positive, the parabola opens upward. While if c is negative, the parabola opens downward. In here, C is not equal to 0. The equation of the parabola is y squared equals 4cx if the parabola opens either to the left or to the right. If C is positive, the parabola opens to the right. If C is negative, the parabola opens to the left. That will be all. Thank you for watching. Please subscribe for more math lessons.